So today we're going to get introduced to inverse functions. So first we're going to start by practicing evaluating functions, and you're going to see something cool happen. So first let's evaluate f of 5. So that means we plug 5 in here. So we're going to do 3 times 5 plus 7 divided by 2. And we could just use our calculator at this point. And when I get this, I would get 11. And then they want me to do g of 11, so we're going to plug it in here. So 2 times 11, it's minus 7 over 3. And remember, when we do this in the calculator, it's 2 times 11 minus 7, and then divide that by 3, so I get 5. Which is interesting, right? Because we got 5 plugged in here and 11 plugged in here, so very interesting. So let's do the same thing for the next one. We're going to do f of 0. So we're going to do 3 times 0 plus 7 over 2, which gives us 3.5. And then we're going to plug 3.5 into the next one. 2 times 3.5 minus 7 divided by 3. Let's see what that is. 2 times 3.5 minus 7, that's 0. All right, so again, we're getting something weird going on. Next, we're going to do g negative 1 first, so we're going to do 2 times negative 1 minus 7 divided by 3. We need to get an answer for that first, so 2 times negative 1 minus 7, then divide that by 3. I get negative 3. I'm going to plug negative 3 into the f function, so 3 times negative 3 plus 7 over 2. And we're going to use our calculators. And divide that by 2, and I get negative 1. Oh, which is interesting, so we go back to that. So we're going to do the same thing for this. We're going to do f of 3 first. So we're going to go 3 times 3 plus 7 over 2. We're going to find our answer. 3 times 3 plus 7. Divide that by 2. I get 8. And then we're going to plug 8 into the g. So it's 2 times 8 minus 7 divided by 3. 2 times 8 minus 7, divide that by 3, and I get 3. So I think we're all seeing a pattern here. So we're going to write it in when the output of one function is used as the input of the other, we get back to the original input, right? We put 0 in and we end up plugging it in, we plug that in, we go back to the original. So there's a special term for equations that are like this with each other. These two functions are examples of inverse functions. Inverse functions reverse the actions of each other, literally switching the roles of input and output. So I put it in here and then it shoots it back to get us back to it. So we kind of saw examples of that happening. So f of x and g of x are inverses of each other. All right, so then we could use this information on tables. So the function f of x and g of x are inverse functions. A table of values of f of x is shown. So draw a diagram that justifies why g of 14 would be 7. So they're saying we already know g is an inverse function. So that means let's draw something that kind of represents it. So if x equals 7, right, and you put it into your f of x machine, right, 7 gives us 14. So then if I put 14 back into that g equation, right, like we were doing above, we should get the answer 7 back. All right, so we're using this idea to make this graph. So instead of putting x, we are going to put negative 16 in, and then we'll get back to negative 3. So we're going to reverse our roles here. So then 0 to negative 7, so negative 7 to 0. 4 to 5, 5 to 4. 7 to 14, so 14 to 7. 9 to 20, 20 to 9. So we're going to flip our roles here. So we switch. Ooh, I spelled switch wrong. Oh my gosh. So switch inputs and outputs. Right? So that's the biggest thing we learned here about inverse operations. We do have to switch them from the table. So we're going to practice this some more on the other side. All right, so then just so you know, when you see inverse functions, there is a special notation for it. We call it, so it has an inverse that is also a function. We call it f, so you see the little exponent negative 1x. So this is what we call our inverse function. The negative 1 in exponent position has nothing to do with exponentiation. So we're not like applying that. We're going to, it's just a notation. We're not going to be adding that to anything. So let's look at exercise 3. So exercise 3, we have this graph. It's already graphed for us. All right, this is our graph with points already labeled. So they label the points. So now let's just do what we did on the front side and let's switch the values so that we could get our inverse. So this is going to become negative 4, negative 3, negative 2, 0, 0, 3, 2, 6, 4, 9, right? So boom, we switched it. Then it says evaluate the following. So f of 0, we go to 0, it is 3. 4 is 9. So you use your new table and boom, makes it much easier. Now it says let's graph these points. So we're going to start with negative 4, negative 3 is right here. Negative 2, 0, 0, 3. Boom, right? So I graphed each of these points. I'm going to use my paper, or you know what, I'll use this as my straight edge. Okay. So let's label it as f negative 1x in parentheses. That's our inverse graph. Every function has an inverse relation. Not all inverse relationships are functions themselves. So now this one's a function. It works. Let's look at an example where it's not a function. So let's see. So given this, which is graphed, right? That's our x squared graph. It's a parabola. Do the following. Based on this graph, create a table of values of the inverse relationship. So let's do x, y. We're going to look at each point. So this point here is negative 8, positive 9, right? Or no, not 8. Silly. Wait, that's 1, 2, 3. Negative 3, positive 9. So let's switch the order. It's going to be 9, negative 3. Let's do the next point. So that's negative 2, positive 4. So then it's going to be 4 first, then negative 2. Let's do the next one. We got negative 1, positive 1, so let's switch it to positive 1, negative 1. This is 0, 0. So that just stays the same. Then we have 1, 1, which that just stays the same. Then we have 2, 4, so then it's 4, 2. And then what is this? This is 3, 9, so then it becomes 9, 3. So here's our values. I took it from the graph and just switched the x and the y. So now it says let's graph this relationship. So I'm going to use these points. So 9, negative 3 is this point right here. 4, negative 2. 1, negative 1. 0, 0. 1, 1. 4, 2, so it's kind of sideways, 9, 3. It's a sideways parabola. Which we know that's not a function. How can you quickly tell the inverse is not a function? Because look, it does not pass the vertical line test. And so what is it about the original function that causes the inverse relationship to not be a function? So this is kind of what we talked about the other day. Remember our 1-to-1 functions with the horizontal line test? This doesn't pass the horizontal line test, so that's how I know this won't give me back a function. So the original is not a 1-to-1 function. And let's write a rule. Only 1-to-1 functions have inverse that are also functions. So that's really important piece that we need to learn here, and we'll do a little bit more with inverse functions in the future.